is equal to T1. We have told you that T1 greater than T2 greater than T3. That is the maxima is maxima which is occurring at some particular value of lambda. We are denoting that one lambda m. So look at this. If we look at this graph, here, the graph is showing that with the increase in temperature, the value of the lambda m is blue shifting. Okay, yes or no? The value of the lambda, this is say lambda m3, this is lambda m2, that is, and this is lambda m1. Now, if we compare this to lambda m1, lambda m3 the point at which the peak arises, lambda m2 is the point where the peak arises, and lambda m1 where the peak arises. If you compare these three, you can easily predict that with the increase in temperature, value of the lambda is decreasing. Yes or no? Lambda m. Got my point?
Yes, sir.
Yes, sir.
So can I say that the value of the lambda m, that is the lambda maximum at which the maxima is occurring, is inversely proportional to 1 by t? Yes or no? Inversely proportional to 1 by t. That is lambda m is inversely proportional to 1 by t. Yes or no?
Yes, sir.
Yes,
Yes,
sir.
This is nothing but an atom which is done by scientist Wiens, that is known as Wiens displacement law. Take the heading Wiens, W-I-E-N, Wiens or Wiens displacement law. Okay, Wiens displacement law. No derivation is required for up to 3 to 4 laws. Then I will come back to that point where we need the derivation. I know that in exam there will be no derivation, but derivation is very much crucial of that point, as most of the critical question can comes from the short idea of the derivation. Okay, so this is known as Wiens displacement law. According to this law, the maxima, that the energy maxima which is appearing at a particular value of lambda varies with a inversely proportional to 1 by t. So this is nothing but called the Wiens displacement law. Lambda m equal to t, or simply lambda m into t is equal to constant. Is a constant quantity. This constant, value of this constant is 2.898. And what will be the unit? Into 10 to the power minus 3. What will be the units? This is lambda. So lambda should be meter into Kelvin. So this is nothing but the Wiens displacement law, or the variation of lambda m with respect to 1 by t. Okay, so this is nothing but called Wiens displacement law, and this is the constant. Okay, the value of the constant. This is very, very crucial to solve the problem. This is very, very crucial to solve the problem. There is a lambda mt equal to constant. Okay. Now, what is the goal of the scientist? The goal of the scientist was to describe the graph in a proper manner. This graph they obtained from the experimental one. Right now they are working on that, how this graph is coming, what is the basic of this graph, and on which phenomena this graph is appearing. So they are trying to fit a theoretical analysis, or they are trying for a theory from which they can predict the graph whatever they achieve in the experimental. So lots of scientists have attempted this. So we'll go one by one. This one is a perfect one, that is shifted to this one. Okay, now next comes number 2, Wiens radiation law. Okay, the displacement law, that is not here displacement, it is showing the displacement of the lambda m, but it is radiation law. Okay, as I told you, at that point of time, most of the people are working on the classical theory. They don't have the idea of the quantum. That time, people generally used to do the quantum thermodynamics. People used to do equipartition energy, from kinetic theory. So Wiens radiation law, at that point of time, applying the thermodynamics law, using using the thermodynamics, using the thermodynamics, Wiens proposed a law where he showed that the total amount of energy distribution, E lambda d lambda total, okay, is equal to A by lambda to the power 5, A by lambda to the power 5 into e to the power minus B by lambda T into delta. Okay, using thermodynamics, scientist Wiens predict a formula that is the total energy distribution. Remember that E lambda y-axis, so total energy distribution A lambda to the power 5 B e to the power minus B by lambda T into d lambda, where A and B are two arbitrary constant. A and B are two arbitrary constant. This equation is known as Wien's radiation law. But the problem, okay, so scientists predicted this one, but the problem with this law is that problem and advantages. This law is only valid. In the low wavelength region. Okay, this law only valid in the low wavelength region, or write it down in this way. This law only explain the experimental result in the low wavelength region. This law only explain, or only capable to explain, the experimental result at the low wavelength region, whereas this law breaks down at the higher wavelength region. So that means if the graph is like this, this law can easily exactly predict up to this point. After whenever we are moving to this one, this law under predicted the result, and we get the exact result in the higher wavelength region. Now look at this.
Sir,
Yeah, go ahead.
upper part is not visible, sir.
Okay. So what I want to say, that is the first one, Wien's displacement law is correct one. Second one, Wien's radiation law. Wien's using thermodynamics predicted a formula. No derivation is required for you. I will come back to this one, how this is happening and everyone little later. But E lambda d lambda is A lambda to the power 5 E to the power minus B by lambda T into this, and A and B constant. This law can predict and can match with the experimental result in the lower wavelength region. That means if this is one in lower wavelength region, why lower wavelength? At lower wavelength, this value will be prominent. But when you increase the value of lambda, this value will dominate. Okay, but that time this law, and what I said, doesn't predict the exact, doesn't predict the value, but doesn't matches with the experimental result. It basically gives under value, that if it is the experimental value, then it will be gives rise to this value. Okay, so with this law we can get up to this point, that is a lower wavelength region. Now, so there is no law that which can explain the upper one, that is this one and this one entirely. So scientists tried again. Okay, then comes with the Rayleigh and Jeans. Okay, then comes with the two scientists. Okay, then there comes to overcome the limitation of the Wien's radiation law, whatever we did one. To overcome this radiation law, scientists Rayleigh and Jeans attempt another way. Okay, he used the classical equipartition theory, and write it down, number 3, Rayleigh's Rayleigh's law. The two scientists, one is Lord Rayleigh and James Jeans. Okay, So to overcome the limitation of the Wien's radiation law, Lord Rayleigh and James Jeans, using the classical equipartition theory, using the classical equipartition theory, classical equipartition theory. I think most of you read in your class 12 in the kinetic theory of gas. Okay, using classical equipartition theory, they predicted that the value of energy in accumulation should be E lambda d lambda. E lambda d lambda is equal to 8 pi kt, 8 pi kt lambda to the power 4, 8 pi kt lambda to the power 4, 8 pi kt lambda to the power 4 d lambda. Okay, from where the equation is coming, I will come back to this point maybe after this class or maybe at the end of this class. So they predicted that E lambda is equal to 8 pi kt. K is the Boltzmann constant, T is the particle at that temperature, and lambda is obviously the wavelength, or 8 pi kt, or he predicted that E lambda is proportional to 1 by lambda to the power 4. E lambda is proportional to 1 by lambda to the power 4. So look at this, this is the formula predicted by Rayleigh-Jeans. Okay, now people tried to fit this formula in the experimental curve. Now, interestingly, this law can only explain the higher order, this is the higher wavelength region, but this cannot predict the shorter wavelength region. Okay, look at this. If we decrease the value of lambda, what will happen? If we decrease the value of lambda, what will happen? Lambda? If lambda
Increases.
Energy will increase.
If lambda tends to 0, what will happen? So basically,
So energy tends to infinity.
yeah, well, what does it mean? That means at lambda equal to 0, lambda tends to 0. What will be the value?
Infinity.
Huh? Yeah, but
So tending to infinity.
yeah, obviously, thank you. It will tend to infinity, yes or no? But is this real curve? No.
No,
Look
sir.
at it.
No, sir.
So in this formula, if we decrease the value of d lambda, then the value should be infinity. But that doesn't true. This is not true. Experimental results showed that it will increase first, then it will decrease. So look at that. Look at the problem. So first with the second one, that is the Wien's radiation law. In Wien's radiation law, be careful with this one. MCQ can come from this one. Wien's radiation law can only predict the low wavelength region, but here it can predict the higher wavelength region. It can predict, or it can matches with the experimental result at the higher experimental condition. Yes or no? Sometimes in your book, maybe you can find out this kind of picture. Look at this. I think it is visible at this point. This kind of picture. This is my experimental car. This is my experimental car. This is my experimental car. And the Wien's, this one, we say Wien's predicted this one and exactly, almost exactly, okay. Up to this point, thereafter it falls. Okay. And here, this one matches with this one, but this is the number 3 Rayleigh-Jeans law, and this one is the Wien's radiation law. Okay, so look at this one. Maybe I can go for this one. Okay, the cross one is the Wien's radiation law. Look at this, it almost matches in the low wavelength region, but it under predict the higher wavelength region. Again, in the dotted one is the Rayleigh-Jeans, it predict in the higher wavelength region, but it miserably fell in the shorter wavelength region. Yes or no? Got my point?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So look at this. Here it is lambda to the power 5. 1 by lambda to the power 5. Here 1 by lambda to the power 4. But here exponential term is there. But here no exponential term is there. Now remember very carefully. In Rayleigh's law, if lambda tends to 0, that means that as per this law, energy should be infinity. But that is not the case. So at this point, at the lower wavelength law, Rayleigh's law fell completely, and this phenomena is known as ultraviolet catastrophe. 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 But why this name? As you can understand from this discussion, that Rayleigh's law fails miserably at the shorter wavelength region, that is 8 pi kt lambda to the power 40 lambda. Now in this equation, if lambda tends to 0, that means E lambda tends to infinity. But whereas the experimental data shows E lambda tends to 0 at lambda tends to 0. This means the Rayleigh's law fell miserably at the shorter wavelength range, and shorter wavelength range is nothing but the ultraviolet range, and that's why it is known as ultraviolet catastrophe. So, or in other words, the serious discrepancy between the Rayleigh's law in the shorter wavelength region with the experimental data and the theoretical prediction is known as ultraviolet catastrophe or Jeans paradox. Ultraviolet catastrophe or Jeans paradox. Okay, Jeans, J-E-A-N, Jeans paradox. Okay, is it clear to everyone?
Yes, sir.
Okay. So ultraviolet catastrophe. Why ultraviolet catastrophe? As in we are going for the Rayleigh's law is not valid in the shorter wavelength region. Okay. So theoretical experimental things predict that at lambda tends to 0, E lambda should be 0. But this one predict that at lambda tends to 0, E lambda should be infinity. So this discrepancy between the experimental result and this theoretical result known as the Jeans paradox or ultraviolet catastrophe. Up to this point, no derivation is required. Write it down. If any book is given that in your syllabus, no derivation is required. Now look at this. We have already defined 3 laws, Quinn's displacement law, that is most of the correct. Prediction is correct, but both Quinn's radiation law and Rayleigh's law fails miserably to explain this experimental graph. One is it matches with the lower wavelength region, another matches in the higher wavelength region. Now, this point, there is no other theory which can predict the experimental graph in a proper manner. That means from bottom to this one, from 0 to infinity, that can explain properly. That is the juncture at which the quantum mechanics evolve, and whatever you are habituated with the term Planck constant, that is the beginning of that. That is to explain this phenomena, to explain this graph, Planck's derived his formula, and the proper idea of Planck's quantization, whatever you read, that is the whenever there will be energy absorbed or release, that will be in terms of quanta. Okay, that will be in terms of quanta, that is E equal to h nu, and this term will comes from this point. Okay, that is the most important point of the quantum mechanics, and that is the backbone of the quantum mechanics. So we have to understand the logic, and we have to understand the derivation. So let's start with this one. So I am repeating once again, to overcome the failures of the Wien radiation law, to overcome the failure of the Rayleigh's law, or more in a broader manner, to overcome the failure of the classical law, Planck introduced the idea of quantization, which is nothing but the ground level, or which is nothing but the base of all quantum mechanics. So let's start with the most important part, that is the Planck's radiation law. That is most important part, Planck's radiation law. Is there any problem up to this point?
No, sir.
Chalo. So number 1 is Planck's This one is the most important one. Very, very important. I don't know how much, but this one, Planck's radiation. Okay, you can follow any book, but just try to understand how it is happening. Otherwise, you will not understand properly. Okay. So, what is the idea? Idea is that Wien's displacement, Wien's has proved at shorter wavelength, Rayleigh's has proved at higher wavelength. By devices an indigenous scheme of the interpolation of this data and this data, Planck gives an idea of avoiding ultraviolet catastrophe. I think at the around 1900 or 1901. I can't remember the exact date, exact year, but from that point, Planck developed a quantum theory of radiation based on few assumptions, or the Planck's predicted the formula on basis of few assumptions. Okay, let's do the assumption part, then we'll go for one by one. Number one, assumption. What is the assumption? Number one. This is very simple. We have already considered this one. Everybody, all bodies inside the enclosure can emit black body radiation. Remember thermal enclosure. If anybody is inside the thermal enclosure, that means they can act as a emitter. That is, all bodies inside a thermal enclosure can emit black body radiation. Number one assumption: all the bodies inside the thermal enclosure can emit black body radiation. These were very simple, and we have already discussed with this one. But now the most important point, this one. How he got the idea at that point, nobody knows. He also don't know, but he have an idea that if we consider this approach, then we can derive the formula. That's all. Okay. Next one, the most important one, the atoms on the wall of the black body, or atoms on the wall of the surface behaves like a simple harmonic oscillator. With a characteristic frequency of oscillation. Okay, write it down. Next one, all the atoms, write it down. All the atoms on the surface of the black body, can act as a linear harmonic oscillator or simple harmonic oscillator, and each having a characteristic frequency. All the atoms on the black body are acting as a simple harmonic oscillator, and they have a particular frequency nu. They have a characteristic frequency particularly nu. Okay. Number three, as I said, this one is the most important, and the next one is also most important. In thermal equilibrium, don't write, just give me, I will explain, then you write. In thermal equilibrium, emission and absorption, whatever the process is going on through this inner oscillator, it is in the form of a discrete packet of energy known as the quanta or photon. Okay, write it down. In thermal equilibrium, emission or absorption of energy by this oscillator occurs in the form of a discrete packet of energy. Energy emission and absorption takes place in the form of an energy packet, and this packet is known as quantum or photon. This packet is known as, in the form of discrete packet of energy, known as the quantum or photon. Quantum or nothing but the photon. And energy of each photon is given by E equal to h nu. E equal to h nu, and nu is the characteristic frequency of oscillation of the oscillator, and h is nothing but the Planck constant. H is nothing but the Planck constant, and the value we all know 6.6 into 10 to the minus 34 joule seconds, or 6.6 into 10 to the minus 27 arc second. Got my point? Yes or no? Joule second and arc second. Yes or no?
Yes, sir.
Okay. So,
Sir,
go ahead. Go ahead.
so like you told that it oscillator can radiate and absorb energy. Then if
Atom.
it
That
will
is
absorb,
the atom. Obviously, the atom.
sir,
Atom.
if it will absorb, then the first assumption will get failed. Na?
Which one?
You told first one that all body will
All body inside the all bodies inside. क्या बोला था? All bodies inside the thermal enclosure can emit black body radiation. Can emit the black body radiation. Okay? वो अगर एब्जॉर्ब करेगा उसको तो थर्मल इक्विलिब्रियम में रहना है, तो वो इजेक्ट करके फिर से इक्विलिब्रियम में आएगा ना? नहीं समझ पाए? सोचो तुम पहले इक्विलिब्रियम में थे, तुम एनर्जी ले लिया, तो राइट नाउ व्हाट विल हैपन? यू विल रिजेक्ट द एनर्जी, देन ओनली यू कैन गेट बैक टू योर थर्मल इक्विलिब्रियम पोजीशन ना? यस सर।
yes sir.
यस रेडिएशन तो होगा। चलो,
और सर एक और क्वेश्चन सर,
बोलो
सर ये मतलब क्वांटाइज्ड होना मतलब क्या होता है?
क्वांटाइज मतलब हम लोग नहीं पढ़े थे क्या? एक क्वांटाइज मतलब क्या? इन टर्म्स ऑफ वन ए फार्मूला होता है E इक्वल टू h न्यू, तो क्वांटाइज मतलब व्हाटएवर द प्रोसेस विल गो ऑन फॉर एब्जॉर्प्शन एमिशन, इट विल बी n h न्यू. That means it can be h न्यू, it can be 2h न्यू, it can be 3h न्यू, but it cannot be 1/2, 1/3 or 0.5, 0.3, 0.7 like this one. Got my point? That is the quantized means this equation produces that E equal to nh nu, or this is the quantization one energy. That means it can only take part in terms of h nu, 1h nu, 2h nu, 3h nu, like this one. Is it clear? Not like h nu by 2, h 1/3 by h nu like this one. So remember, the electron charge of an electron is the minimum. That time with the charge is quantized 1e, 2e, 3e like this one. Got my point? That is not
Means
here.
quantized is it means the value.
N means, sorry?
Means quantized is a value.
Quantized means in terms of how much. Suppose we are exchanging energy, me and you. So that should be maybe 2h nu, maybe 3h nu, but it cannot be 1/2 or in way. N should be the natural number 0, 1, 2, 3 like this. Okay?
Okay, sir.
Quantization. Okay? So number now last one in this assumption, that is the number 4. This is maybe you have to remember, but I will explain in the statistical mechanics. That is number 4. Number of oscillator per unit volume per unit frequency range. Okay. Number of oscillator per unit volume in the frequency range nu to nu plus d nu. That d nu is very small. Okay, that the number of oscillator per unit volume in the frequency range is nothing but 8 pi nu q square by c cube. 8 pi nu square by c cube into d nu, and this is nothing but the number of oscillator in nu d nu. Number of oscillator in nu d nu, or simply this one. Okay, number of oscillator, how many number? मैंने बोला था शुरू में, that is they are all the atoms are acting as a oscillator. How many number of oscillator are present? That is this I'll explain in the statistical mechanics. No derivation is required for this one. Okay, we have to use this one. In nu, that is the number of oscillator within the frequency range d nu. That is nothing but 8 pi nu square by c cube in this one. Okay, is it clear to everyone? I'll explain this one how it's coming.Maybe if you want in the statistical mechanics. Right now, just take this as a simple number. So maybe the number in the body should be per unit volume into this number, that is the total number of it. I'll come back to that point little later. So these are 4 basic assumptions. Planck's Planck's consider on the basis of which we will derive the Planck's law. We will derive the Planck's law. So now the derivation. Okay. Now the derivation. What I will do, I will find out the total energy. That is, remember, we have to find out the E lambda d lambda. That is the total energy over that one. Okay. So this is very simple if you understand this one, but it will be very complex if you don't understand. So try to understand and raise your query at every point. If you do not understand, I will repeat multiple times. Don't worry for this one. So let n be the total number of total number of oscillator, and E be the total number of total energy. This one. N is the total number of oscillator and E is the total energy. Okay. So if I ask you what will be the average energy, what will happen?
E by N.
Thank you. Simple. So the average energy, average energy of the oscillator, of any oscillator, say that is I am writing without terms of curly this one as it is written in the book, nothing else, you can choose anything. So this is nothing but E by N. Yes or no? Is it clear or not?
Yes, sir.
Okay?
Yes,
Now go back to your class 12 days. So we have already told that times, or maybe I have not told you the laser, that otherwise it will be easier. So can you remember that the atoms are distributed in an energy level? Yes or no? At the ground level, that will be maximum. That whenever we go for excited state, then it will be increases. Yes or no?
Yes, sir.
Yes, sir.
Atoms are arranged in a particular energy level. At the ground level, that will be maximum. At upper level, that will decrease. Yes or no? Got my point? Okay. So can I say? So take this one. Let n0, n1, n2, n3 dot. It can be nr up to nr, etc. Are the atoms are the number of oscillator with the energy 0, E, 2E, 3 like this one. Now is the left n0 n there is the number of oscillator with energy. How much? Prince, I told you that time it's 0, E nu, H nu, 2H nu like this one. Say 0, E, 2E, 3E, dot. That is how much? Last one should be R. This one R. So RE plus this one. RE in R. So RE. Okay. Yes or no?
Yes,
Sir, N0, N1, what are these?
What is it?
What is this N0, N1?
N1, I told you that is there are energy levels. Okay, this is energy ground level, upper level, top level, like this one. N1 is the number of atoms in the ground level. N0, N1, N2, N3, like this one. So here N0 is the number of atoms which doesn't have any energy. N1 has an atom, H nu, N2 has atom, 2H nu, N3 has atom, 3H nu, like this one. So N0, N1, N2 are the number of oscillators with the energy 0, E, 2E, 3, RE. Okay, and E is nothing but H nu. What's my point? Yes or no? Where E is nothing but what? H nu. Is it clear to everyone?
Yes,
Is
sir.
it clear to everyone? Can we write this step? Easily from this one? N is the total number of oscillator is equal to N0 plus N1 plus N2 plus N3 dot Nr. Yes or no? हमने लिया था N0, N1, N2, N3. So total number of atoms should be like this one. Oscillator should be this one. Yes or no?
Yes, sir.
Sir, but ground level has 2 atoms.
No, I never told you 2 atoms. Who told you 2 atoms?
Sir, in atomic theory, octet.
No, you are not going for the atomic theory. Don't worry. I am not saying any kind of things. You are going for 1:2, 2:2. Don't go for that. Okay? So, N0 is the number of atoms at the ground level. Okay? At the ground level. Okay? And this one, that is the energy of 0. This is N1, N2. This is total number of atoms. Okay? Then what will be the energy expression? What will be the total energy? Anyone? How can we express this one? What will be the total energy? Can we write this one? N0 number of atoms with 0 energy. N1 number of atoms with E energy. N2 is in the words. Can we write this one? N0 into 0 plus N2 N1 into E1 plus N2 into E2. Yes or no? What my point?
Yes, sir.
एक का एनर्जी 0 है, इसका एनर्जी E है, इसका एनर्जी 2E है. So the total energy should be number into energy, number into energy, number into energy. Yes or no? Is it clear?
Yes, sir.
Number of
Yes, sir.
oscillators into the respective energy. So this can be the total energy. Yes or no?
Yes,
Is it
sir.
clear to everyone?
Yes, sir.
Yes.
Yes.
So this is now. Can you remember what is the if N0? Can you remember the Maxwell-Boltzmann formula? What is the relation between N0 and N1? Anyone? What will be the relation between N0 and N1 from your class 12? Anyone? Anushrita,
So N1 equals to N0 E minus KT.
yeah, thank you so much. Can we write this one using, I will also discuss in a maybe, if I will take that one, statistical one, I will discuss, otherwise Edison will discuss if he wants us that point. Using MB, that is Maxwell-Boltzmann distribution, using Maxwell-Boltzmann distribution, the number of oscillator in this one can be written as N1 is nothing but N0 e to the power minus E1 by KT. Yes or no? Is it clear or not? Is it clear or not?
Yes, sir.
तो N2 क्या होगा? N2 क्या होगा? Anyone? N0 e to the power minus
2 KT.
Only
2E1.
2E divided by KT.
This should be in ground level. हम लोग E लिए थे, तो 2E by KT. Yes or no? Is it clear?
Yes, sir.
तो N3 क्या होगा? इसके वजह से N3 क्या होगा? N0
And not e की power minus of 3.
ठीक है? Is it clear to everyone? अब चलो
Yes, sir.
इसको बिठाओ, यहाँ पर बिठाओ, यहाँ पर बिठाओ, क्या होगा? एक सीरीज आ जाएगा, तो N0 की जगह पर N0 इस N में बिठाओ, इसमें बिठाओ, that means यहाँ पर बिठाओ, यहाँ पर बिठाओ, यहाँ पर बिठाओ. चलो क्या मिलता है? N0. ठीक है? उसके बाद N1 की जगह पर क्या बिठाओ? N0 e to the power minus KT. Yes or no? N0 e to the power minus E by KT. Next one, क्या बेटा? N0 e to the power minus 2 KT. N0 e to the power minus 2E by KT. Yes or no? Dot dot dot. Is it clear to everyone?
Yes, sir.
Yes, sir.
Clear to everyone?
Yes, sir.
तो उसको क्या लिख सकता हूँ? Anyone?
And not common ले लेंगे. E to the power minus KT को एक well.
N0 इसको कॉमन लेके मिलता है A इक्वल टू N0. ठीक है? उसके बाद क्या लिख सकता हूँ? 1 प्लस e to the power minus E by KT plus e to the power minus 2E by KT, simply e to the power minus 3E by KT, dot dot dot. Yes or no?
Yes, sir.
Yes, sir.
तो इसको लिख सकता हूँ ना? अगर इसको एक ले लो, सोचो से क्लियर है ना अप टू दिस पॉइंट? हाँ क्लियर. चलो अगर e to the power, सॉरी,
एक सीरीज आ गया सर.
ले लो तो ये x से पावर आ जाएगा, ये x क्यूब हो जाएगा.
Sir, GP.
Geometry progression.
ये 1 x square x cube like this one. Yes or no? So
Yes, sir.
say e to the power minus E by KT equal to x. तो क्या होगा? तो उसको थैंक यू सो मच।
1/1 माइनस एक्स हो जाएगा सर जी।
हाँ थैंक यू प्रिंस, अभी इसको प्रिंस पढ़ लिया छोटा, मतलब चलो इन नॉट 1 प्लस एक्स स्क्वायर प्लस डॉट डॉट डॉट, ये समझो। इसको मैंने
Yes, sir.
इसको x लिया तो ये सीरीज आ जा रही है। ओके, दैट मींस इसका वैल्यू क्या होता है बेटा, इसका सीरीज का वैल्यू है 1/1 माइनस x होता है ना, हाँ कि नहीं? ये
Yes,
टोटल सीरीज का वैल्यू 1/1 माइनस x होता है। तो n नॉट का वैल्यू क्या होगा? तो n इक्वल टू n नॉट का वैल्यू क्या होगा? कैन वी राइट दिस वन यहां से, दैट इज n इक्वल टू n नॉट 1/1 माइनस x। इसका मतलब क्या है? 1/1 माइनस x, दैट मींस n नॉट 1 by e to the power this one, that is 1 minus e to the power minus e by kt. What is yes or no?
yes sir.
Clear to everyone?
Yes, sir. Yes, sir. Yes, sir.
Clear to
Yes, sir.
ठीक है। अब नाउ द एनर्जी एक्सप्रेशन, फिर से एक ही करो, क्या मिलता है करो, ठीक है। सेम सीरीज आएगा लेकिन थोड़ा डिफरेंट सीरीज आएगा। एनर्जी के लिए सेम सीरीज आएगा लेकिन थोड़ा डिफरेंटली आएगा। क्या आएगा से देखो, एनर्जी का एक्सप्रेशन क्या लिखा मैंने, E इक्वल टू 0 into n0 प्लस n1 into e1 प्लस n2 into e2 प्लस n3 into e3 डॉट डॉट डॉट। ओके, तो डालो क्या मिलेगा, पहला वाला तो 0 ही होगा, 0 प्लस n1 के जगह पर बिठा दो, क्या बिठाओगे, n1 के जगह पर बिठाओगे e1 n0 टू द पावर e1, तो मतलब e1 मतलब e, सॉरी ये क्या लिखा था, ये 2 ही लिखा था ना, 2 ही लिखा था या e1 लिखा था?
2 2
इसको 2 ही करो, तुम लोग बोल नहीं बोल रहे हो, मैंने ये n2 into 2e n3 into 3 इस हिसाब से लिखा था ना, ओके नहीं? देखो हो रहा है कि नहीं हो रहा है?
Yes sir.
0 into n0 n1 into e n2 into 2e n2 in 3, तो यहाँ पर क्या मिलेगा, n1 के लिए क्या लिखूं, e to the power minus e by kt, n2 के लिए क्या लिखूं बोलो, anyone?
2e and not
e to the power minus 2e by k.
then उसके बाद
3e and not e to the power
Sir,
minus
same.
3e by k.
and not to the
Sir,
power
it will be same only into e.
कोएफिशिएंट will change.
ठीक है, तो ये डॉट डॉट हो जाएगा, तो इसको क्या आ रहा है, इसको इक्वेट, इसको
Sir, sum will be same only into e.
into e आ जाएगा, एक स्क्वायर आ जाएगा आई थिंक, तो e इक्वल टू कैन आई राइट दिस वन, क्या कॉमन ले सकते हो, e कॉमन ले सकते हो, n नॉट कॉमन ले सकते हो, ये सुन लो, सो कैन वी राइट दिस वन e into n नॉट, ये क्या आएगा, अगर इसको मैंने x ले लिया तो इसको मैंने x लिया से क्या मिलेगा, इसको x लिया तो क्या आएगा, एनीवन?
x कॉमन हो जाएगा,
x कॉमन हो जाएगा, n नॉट को ले रहे हो तो x को कॉमन हो जाएगा ना, तो x कॉमन हो जाएगा, x कॉमन हो जाएगा, इसके बाद 1 प्लस हाउ मच, 2x
plus 3x square.
3x, इसके बाद लाइक दिस वन, ये सब पॉइंट बाय पॉइंट।
Yes, sir.
Yes, sir.
ये भी एक सीरीज हो गया,
APG
1x plus 2x plus 3x square, what is the series, what is the value of this
APGP.
APG
AGP, sorry.
value কত,
1 minus x comes.
1 minus x square है, APGP করে दूसरी तरह পড়াশোনা করেন, APGP করে 1 minus x square whole square। okay, is it clear to everyone? is it बेटा?
Yes sir.
इसको मतलब हर मुंह में आना चाहिए, 1 minus x square by, yes, is it clear or not? is it clear or not?
Okay.
क्या है, तो इसको क्या आ रहा है, एप्सिलॉन n नॉट into x by 1 minus x square, is it clear or not? is it clear or not?
Yes sir.
ठीक है, तो मेरे को क्या चाहिए, वी आर ऑलमोस्ट एट, मतलब जो गंदा काम था हो गया, ये क्या है, तो e into n नॉट x by 1 minus x square, ओके, तो इसका मतलब होता है e इक्वल टू e into, ये मतलब h न्यू होता है जो भी है, ये n नॉट हुआ, x के जगह पर क्या बैठा e into e power minus kt divided by 1 minus e to the power minus by kt whole square, ये सब। Is it clear? Is it clear? x के जगह पर मैंने बैठा दिया। Is it clear to everyone?
Yes.
Yes,
Yes,
sir.
sir.
अब
Yes, sir.
ठीक है, कितना टाइम? 2 मिनट बाकी है, तो इसको ज्यादा नहीं बढ़ाऊंगा, खाली एवरेज एनर्जी करके छोड़ दूंगा, बाद में एवरेज एनर्जी क्या है? एवरेज एनर्जी क्या है? E by L, आखिर नहीं, एवरेज एनर्जी क्या है? तो क्या मिलेगा? निकालो, क्या मिलेगा? E का वैल्यू ऊपर में लिख दिया, E into n naught e to the power minus E by kt by 1 minus e to the power minus E by kt whole square। n का वैल्यू क्या है? क्या निकाला हम लोग? n का वैल्यू क्या निकाला? n का वैल्यू
Not that 1 minus e to the power minus
e
1
to the power kt by n naught, yes or no? तो इसका वैल्यू निकाला 1 minus e to the power minus kt by n naught, yes or no? हाँ कि नहीं?
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
तो क्या आ रहा है?
Sir,
Sir,
and
E minus
1
E
minus
by KT.
कट जाएगा।
ये स्क्वायर कैंसिल हो जाएगा, ये an कैंसिल हो जाएगा, ये n नॉट कैंसिल हो जाएगा, ये सुन लो। तो कैन
Yes,
वी
sir.
राइट दिस वन?
Yes, sir.
e to the power minus e by kt by 1 minus e to the power e minus kt। Is it clear or not? Is it clear?
Yes, sir.
ठीक है?
yes, sir.
Yes.
हाँ, इसको दोनों को डिवाइड कर दो, इसको कट जाएगा, थैंक यू। तो ये क्या आएगा? इसको लिख सकते हो e into e to the power e by kt minus 1। इसको ऊपर इसको डिवाइड कर दिया, इसलिए माइनस, ये प्लस होगा, 1 बाई माइनस था, ये प्लस हो जाएगा, -1 होगा, ये सुन लो।
Yes, sir.
Yes, sir.
Yes.
तो इसका वैल्यू क्या है? तो इसका वैल्यू हम लोग क्या लिख सकते हैं? एनर्जी एवरेज, ई का मतलब होता है h न्यू e to the power h न्यू by kt minus 1। बाकी नहीं, आज का यहाँ पर खत्म करते हैं, बाद में जाके नेक्स्ट दिन यहाँ से 3-4 लाइन ज्यादा है। मैंने हम लोग assumption लिए थे n equal to 8 pi square न्यू स्क्वायर d क्यूब, वहां पर इसको मल्टीप्लाई कर देंगे तो रिजल्ट आ जाएगा। I will not go as I have a class once again, but this point, up to this point, is there any problem? Up to this point, is there any problem? Up to this point, is there
No,
any?
sir.
एक बार देख लो, guys. This mathematical derivation is very crucial. This mathematical derivation is very crucial as this is the backbone of all the derivation or all the mathematical problem which will appear in the semester or which will appear in the other part of the derivation. Okay, so this is very crucial, where we have today we have find out the average energy. Okay, is it clear to everyone? Is it clear to everyone?
Yes,
Sir, what
Yes,
is
sir.
epsilon?
What is epsilon? It's small, just this one. Which one? This one.
No, sir. This this one.
This is just small. This is small e in terms of e equal to h nu, just to, not epsilon. Epsilon.
No, what does it represent? Like energy per molecule or something like that?
E equal to h nu. That's why this is small e or epsilon. Okay. Energy per oscillator. That is the quanta, discrete quanta. It can take. If there is exchange of energy between me and you, then it will be in terms of h nu, 2h nu, 3h nu, like this. Okay, is it clear to everyone?
Yes, sir. Yes, sir.
तो अगर e लिखने में ये प्रॉब्लम हो रहा है, इन दोनों को खाली डिफरेंट करने के लिए मैंने लिखा दिस इज e, ये e नहीं हो सकता, तो इसको ये टोटल एनर्जी और ये कार्ली मतलब कार्ली लिखा, कार्ली बार मतलब एवरेज और कार्ली मतलब e equal to h और कुछ।
Sir, E is epsilon 0. It is energy per atom or what?
नहीं है, এপসাইলন নয়, ব্যাপারটা ভালো করে বোঝো, তুমি বুঝতে পারছো
ঠিক
না?
আছে, কার্লি ই যদি হয় মানে ওটা রিপ্রেজেন্ট কি করে?
সেটাই তো করলাম আগে, এনার্জি পাওয়ার কোয়ান্টাম। ই হচ্ছে টোটাল এনার্জি, ই টোটাল এনার্জি, সরি টোটাল এনার্জি, ই টোটাল এনার্জি। দিস ইজ এনার্জি অফ ফোটন, এনার্জি অফ ফোটন ই or this one equal to h nu, or simply you can write E also.
হ্যাঁ এটাই জিজ্ঞেস করছি আমি, এনার্জি অফ ফোটন, ঠিক আছে।
সেটা তো প্রথমেই বললাম নাম্বার 3 পয়েন্টে, দ্যাট ইজ দ্য অ্যাজাম্পশন বাই দি প্ল্যাঙ্ক।
सर क्वेश्चन है सर।
हाँ बोलो
सर पहले हम लोग लिख रहे थे n इज इक्वल टू n नॉट प्लस ये सर
Yeah.
सॉरी e इज इक्वल टू n10 प्लस n1 e1 प्लस n1 n2 e2 ऐसे करके लिख रहे थे। फिर अभी बाद में हम लोग लिखे सर n नॉट सर इनटू सर 2e1 प्लस 2e2 सर 3e2 सर ऐसा क्यों 3e3 ऐसा क्यों लिख रहे हैं सर?
पहले क्या आया था, पहले एक n आया था n नॉट n1 n2 लाइक दिस वन, ओके।
हाँ सर फिर
n नॉट क्या है, n नॉट इज द एट द ग्राउंड स्टेट एट द 0th लेवल,
यस सर
n1 is the one level, n1 is the second level, तो इन दोनों के बीच का रिलेशन क्या है, n1 equal to n naught e to the power minus e by kt ना,
यस सर
n2 equal to n naught e to the power minus 2e by kt ना,
Yes,
like
sir.
this one. So
Yes,
can I, so just using this one here and put the derivation as simple,
ओके ओके सर
ठीक है। चलो मेरा क्लास, बाय।
थैंक यू सर।
Thank you, sir.